All right, welcome everybody. My name is Matthew Champa, and I'm an electromechanical member of Team 930.
I'm Ellery Wagner, and I am the electrical sub.
In this presentation, we will be covering component placement, wire management, connectors, soldering, sensors, and battery care. Electrical encompasses the movement of all mechanical parts. This can include directly powering a motor, powering a compressor, powering electrical components, and much more. Electrical work requires a variety of components to be completed. Throughout this presentation, we will focus on management and organization of electrical elements, and our team manager utilizes these elements. Good component placement includes the placement of components in a way that allows them to remain safe on the robot, as well as placing them in such a way that minimizes obstruction to other areas of the robot, maximizes robot efficiency, and allows anyone to work on the electrical panel with ease. For example, placing motors low on the robot keeps the weight distribution of the robot near the base, keeping the robot from being top heavy, and placing components on a belly fan helps avoid electrical components from being hit by other robots or moving parts. To place electrical components as efficiently as possible, we must take into consideration many factors. This includes the location of surrounding components, where you place wires in your PDH, and the distance between components. To do this, placing your component placement is essential. This can be done through a wire map with your power distribution hub, as well as planning the location of components such as breaker, radio, and robo-reel before placing any components. As you can see, our wire map includes a description of what component is being used, as well as a description describing what each component's function on the robot is. This aids the programming team as well as the electromechanical team by having permanent reference of where each wire is routed on the PDH. Another essential part of planning component placement is taking into consideration wire routes. This includes planning what wires go into which ports. When deciding what ports to put wires in, you consider which port will have the shortest route to the component you're working with. By taking these steps when deciding where to put your components, you can increase efficiency and ease of access to your electrical panel. Also, by having your electrical panel planned out beforehand, you minimize the number of times you need to adjust your component placement, keeping your electrical panel organized. In this diagram, you can see how the component placement increases efficiency. Components are oriented to allow wires to have as short of a path as possible to the main wire route. By doing this, you increase the ease of access to your electrical panel, keep wires as well as components organized. Good wire management allows wires to be worked on efficiently and remain out of the way of moving parts of other robots. This can be done through zip ties, key string tubing, wire sleeving, and wire twisting. Zip ties, the cheapest and easiest way to manage wires, can be used to keep multiple wires tied together as well as move wires against another object. This can be seen on our 2022 robot, where we use zip ties in multiple places to keep the wires against the drivetrain tubing. This is an example of zip tie usage on our 2022 robot. As you can see, by using zip ties to keep wires against the edge of the tubing, we prevent possible damage to the wires and pneumatics by moving parts in other robots, as well as increasing overall efficiency and organization. Heat shrink has two main uses in wire management. It can be used to effectively protect solder pieces of wire, keeping the exposed area protected from other wires and possible external damage. Similar to zip tie, it can also be used to hold wires together, and move wires to be routed together easily. I will be doing so Ellery can hand out the examples I have, and I'll also be doing a demonstration. In general, you want to make sure you don't have the metal part of the heat gun when you're doing this touching any components, or they will melt.
You know that from experience?
Nope, not yet. Here is an example of how I use heat shrink on our 2022 robot. This example shows how heat shrink can be used to project solder on a wire and how heat shrink can be used to hold wires together. Here you can see it's not shown, but you can see where the bumps and where solder is under there. Wire sleeves, which is the one shown on our 2020 robot here, are used to protect wires and root wires in areas where zip ties, heat shrink, and other options aren't as applicable. Here's an example of the same material we use on our robot. This example demonstrates how using wire sleeve can remove wires from damage. The wires shown in this example are routed through an area with moving parts. As you can see here, this whole metal contraption moves when the engine is going. By using a wire sleeve, you protect wires from moving parts as well as other robots. Alright, so while wire twisting is used to twist two wires together to increase organization and efficiency, it is mostly used to connect two wires from going to the same area by using something like a zip tie to connect them. This is especially used for longer wires that would otherwise be very time consuming to zip tie the entire room. I'll also give you a demonstration of this wire twisting. And this is what it's not look like. It done a little bit better, but this example shows how wire twisting can be used to increase organization of electrical wire roots by allowing two wires to go to the same place and be routed as if they were one. I've given you mostly examples of good wire management. This is an example of bad wire management. There are a few things wrong with this diagram, including wires being routed through moving parts, as you can see here. Be caught and chained to the robot. Many wires just in the air floating, which can be easily caught by other parts on your robot or by another robot's intake, for example. And miscellaneous. And finally, this kind of wiring keep anyone who hasn't worked on a panel before from actually doing any work, as most of the time is going to be spent figuring out which wires go to where. Being able to work on your electrical panel and electrical components in general is essential in competition. In general, good wire management allows team members to easily pick up issues in the wiring and fix them quickly. Good wire management also allows someone who hasn't worked on the wiring before to understand the layout quickly and easily, increasing the efficiency of electrical work on your own. This is especially helpful in competition when wiring issues needs to be fixed efficiently during competition.
So when wiring a robot, there are two main ways to extend or connect wires. The first way is to use connectors, which also helps prevent shorts. The main types of connectors that Team 930 uses are vampire connectors and Anderson connectors. Matt, do you want to pass out vampire connectors? So vampire connectors, we usually use them with CAN because they are made for smaller wires. And I like them because you do not just have to strip the wires prior to use, which is helpful because when you're hurrying and you strip a wire, you can break copper strands and that can cause damage. And then the other type we use is an Anderson connector, which we use with batteries and extending motor wires. These are very secure but are easy to disconnect purposely. The other way is the soldered, and this is done by connecting the wire strands with a filler metal. And here is the setup for it. And later on, if anyone wants to try, you can try to do that. And soldering is beneficial because it can be used with any gauge of wire, and it can connect more than 2 wires, and is often cheaper in the long run. So, yeah.
Sorry, can I ask a quick question? How hard is it to pop the vampire connectors back open if you have to change stuff?
Yeah, that's a little time consuming. It can be pretty difficult to open.
I haven't used them, so I'm asking.
And there was a picture of this earlier, but this is a horrible example of soldering. Yeah, this made me cry. Anyway.
Did someone do that purposefully like that, or was that like you give a freshman a soldering iron?
This was purposeful.
Okay.
So it doesn't have, like, it's not connected by all the strands, and it's not protected, and there's a lot of extra solder. And these ones. These ones are a better example because it's protected on this one. This one I took it off just to show it, but all the wires are covered in solder and there's not a lot of extra solder. Okay, sensors are very important in first for the autonomous mode of play and time constraints. Since every match is 2 minutes long, with the goal to score as many points as possible, sensors help to decrease the amount of time this usually takes and makes it more efficient. We mostly use proximity sensors, line break sensors, and time of flight sensors. In the 2022 Climber, we use metal proximity sensors, which sense the end game of bars and close the clocks autonomously. This increased the efficiency and speed of the climb, which led to more points scored in competitions. So we have an example.
Bring out your safety glasses.
Okay. So this is the metal proximity sensor, and when it senses it, and then disconnects it. So that's just what we use for it. And then line break sensors, they use infrared beams, and when these beams are broken, it signals that there is an object. And in our case, we use these to detect the location of cargo in the indexer. Time of flight sensors have a similar purpose, but we use these in our shooters since infrared on the field was interfering with the line break sensors. They are also beneficial because they also detect the distance. Okay. Batteries have a vital role in the success of a robot. It doesn't matter how good a robot looks or how well it climbs if the battery doesn't work. So this is why Team 930 has stressed battery care. This helps keep all batteries in good condition and reduces the risk of injury, elongates the battery's life, and keeps organization in the craziness of competitions. The process begins with always holding the battery in two hands, because if you spill it, that's really bad. Then the next part is to only connect batteries when components are off, and this avoids damage to yourself, the component, and the battery. Team 930 keeps battery logs, which helps us rotate batteries properly and keeps them in the best condition. So I'm going to go through the battery process. Here it is. So we have our battery, and we are taking this one, and this is, let's pretend this is for our off-season robot, and this battery is 930-2022-02 AC. Oh, 2020, sorry. Okay, and we have our little battery beak, and you just put it on here. And this will tell us what voltage is and the resistance. So it's 13.142. And the resistance is 0.018. And if we can see no damage, we can leave that blank. And if there's any other comments, we can put those in. And then we would submit it, and it would go to a log, so we can look at for future reference. And through this system, we found the battery, we found this battery, which it doesn't look damage on the outside, but because we recorded information about it, we were able to see that it loses charge really easily, so this helped us to take it out before it damaged our performance in competitions. In this presentation, we looked over how component and wire placement increases efficiency and causes less damage. We looked at how connectors and soldering connect wires. We looked how soldering is often cheaper and connectors decrease shorts. We looked at how sensors can automate processes and make tasks easier. And finally, we looked at battery care as a safer way and how it increases battery life.
Thank you for watching, or thank you for listening. If you have any questions or need clarification on anything, feel free to ask us. Also, if you would like to